Today we're going to do some reviewing of some linear concepts. So first thing we're going to look at is a graph. So on this graph to the right, you'll see here, I don't have any pretty points or any dots on the line. So we're going to start with that. We're going to look at this graph to see where does the line cross the grid at like an obvious T location, and we're going to put a dot there. I suggest you always start with this. So like over here, I can see at -10, looks like it crosses at 4. Another one would be looking at -5 and -2. Another one here at 0, -8. And that's actually it. We only need 2 points to find the slope, so we have more than enough than what we need. For the rise and the run here, the rise is going down from there to there, between these two, and then the run is going to the right, this direction here. So that the rise would be down 6, it looks like, so a -6, because this is going down 6, so -6. And then to the right here, we're going 5. So this is the run, and this is the rise. And it makes sense that this is negative because this slope is this line is negative, going down from left to right. This little person would be sliding down, which means the slope is negative. So our slope is the rise over the run. So our slope here would be -6 over 5, rise over run. And then for our equation, it's always y equals b plus mx. B is where it begins. That's the y-intercept, where it begins. And m is how it moves. That's the slope. So our y-intercept is where it crosses the y-axis. So over here, if you look at the y-axis here, the line crosses there at -8. So our b value is going to be -8. That's our y-intercept. So then for the equation, it's y equals -8 plus -6 over 5x. But of course, we don't need a plus and a minus there. You could just do y equals -8 minus 6 over 5x. Okay, for the next one here, let's start with the y-intercept. Let's see if we can find that first. Here it is at -6, so b equals -6. And let's find another pretty point here. Looks like that would be a good spot, or this would be a good spot. A lot of good options here. So I'm going to put dots on there, and then I'm going to again do rise over run between any 2 points. Looks like a 2 and a 3 there. So the rise is 3, the run is 2, so our slope is the rise over the run. So that's the 3 over 2. So then our equation would be y equals our y-intercept -6 plus 3 over 2x. For the next thing here, very similar. We're going to just find the y change and the x change this time. So we're going to use any 2 points in our table to find the y change and the x change. Let's actually start with the y-intercept though, because that's right here. At 0, this is our b value, our y-intercept. So b equals -6. And then our y change here from 8 to 22, just do 22 minus 8, and that's 14. This is a plus 14. And then from 8 to 16 there would be a plus 8. So 14 over 8 would be our slope, which you could simplify if you'd like. You could call this 7 over 4. That's equivalent to 7 over 4. So that would be our m, because it's the y change over the x change. So our equation then would be y equals the b plus our slope times x. That would be our equation for that one. For the next page, very similar here, except you don't see a y-intercept. So the y-intercept would be actually in between -3 and 3. Right in the middle would be an x of 0. So I can use this to kind of find the middle here, and you can hopefully figure out what that is. In between -5 and -7 would be a -6. So that's going to be our y-intercept. So a lot of -6's here for y-intercepts. That just happens to be here. And then our y change is -2. It's going down by 2 to -11 from -9. And then the x change from 9 to 15 is +6. So our slope would be the y change over the x change, which is -2 over 6. Or we can call that -1 over 3. Same thing. So for our equation, y equals the y-intercept plus the slope times x. I don't need a plus sign there though. If it's negative, just call it minus 1/3 x. Okay, on to the next examples here. So these examples you'll see in your packet too, if you're looking at the 2 points practice. Finding the equation of a line that goes between 2 points is a little bit tricky because we don't always have the y-intercept given to us like this. And we don't in this case because there's no x of 0. So I'm going to make a table. And I'm going to show enough points here to get me to 0. So I'm going to start with 0 here, even though I don't have it. And I'm going to fill in all the way to 6. So 1, 2, 3, 4, 5, 6. So 6 is at 13, 4 is at 9. So our y change here is 4 for every 2. So our 4 over 2 is 2 over 1, which means that this would be a plus 2, which is 11. And that makes sense because that would be a plus 2 to 13. So 4 for every 2 is the same as 2 for every 1. 2 for every 1. So then working backwards, if this is plus 2 this way, this has got to be 7. Same thing, that's got to be 5, 3, and then 1. Just again, following this pattern backwards. So now we've got the y-intercept at 1, and our slope is 2. So our equation would be y equals the y-intercept plus 2 over 1, or 4 over 2, or 2. They're all equivalent. Y equals 1 plus 2x. For the last one here, very similar. Let's make a table. Let's make sure we got room for 0 on there. We have 1, we have 5, so I'm going to go 1, 2, 3, 4, and 5. So 5 is at negative 25, 1 is at negative 1. So this y change, if you use your calculator, you can do that on there. Do negative 25 minus negative 1 becomes a plus 1, which is negative 24. So we're going down 24 as this goes up by 4. So the slope would be y change over x change. Sorry, that's sloppy. So negative 24 over 4, which is equivalent to negative 6 if you just divide them. So that means for every 1 change in x, we're going down by 6. So that would be a minus 7, would be a minus 13. Another minus 6 would be a minus 19. And that's why it's a negative 25 there, because negative 19 minus 6 is negative 25. And then working backwards here, that would have to be a plus 6 here, which would make the y-intercept 5. So there we have it. Now we can then write our equation. So y equals our b plus the slope times x. Again, don't need the plus sign there. If I have a negative, I can just call it subtracting. So hopefully you found that useful. I know that was a lot at once here, but you can definitely watch more videos that I've attached to my assignment for this if you need more examples.